My name is Modar Alawi. So as he introduced, I am founder and CEO of Iris. I want to thank each and every one of you for being here on a Saturday morning, but I don't blame you for being here at this beautiful venue. I had the pleasure to meet, mentor, and also learn from some of the brightest and most inspiring minds in Morocco, entrepreneurs, young and not, who have different ideas, creative ideas, great quality, great products, and I couldn't be more thrilled and proud of my Moroccan community of entrepreneurs. So today it is about Iris. We're going to talk a little bit about how Iris came about. I'm going to give a little bit of a background, and after that, we'll be talking about some other things. I do have, however, a slide where I want to set some expectations. So we have about 30 slides. We're going to spend about 1 minute per slide. So that's about 30 minutes, and I want to leave about 10 minutes for Q&A. Very important for me, so I can learn from people's questions, and it's also a way for me to validate whether my message got across or not, depending on the questions. So we'll be covering deep learning, something that is the underlying platform for Iris. We'll be covering the Iris technology overview. We'll be covering its current applications in the marketplace, and then ambient intelligence, and all of these things are interrelated to each other. So it's not like just, subjects that are just independent from each other. I'm going to be covering the fourth industrial era, or the era of AI. Lastly, the mobility revolution. If we have some time, I may have another slide for just the state of the Moroccan scene, the Moroccan startup scene. But I don't want to take the thunder away from the panels that we have later on today. You guys have a beautiful, most wonderful program that's coming up. And then we're going to adjourn, hopefully, in 40 minutes from now. So a little bit of a background. My name is Modar Alawi. I was born in Fez. After high school, I moved to Montreal, Canada. I spent a few years between HEC and Concordia University. I graduated in 2004 in marketing and advertising, but most importantly, I graduated with a major called Integrated Marketing Communications, which is kind of a fancy word for advertising. My focus was consumer behavioral measurements, or user behavioral measurements. So that's kind of something that I discovered early on that I like. It is a self-discovery, something that's very important in entrepreneurship, that you know what you like, and also you know that how to use it for which problem, right? So early on, I discovered that something that fascinated me is some of the most important hardware technologies have all been inspired by the human or the animal anatomy. So take, for example, the eye-shaped cameras that provide a wide dynamic range, so a camera that is on a shape of the eye. Or take, for example, to your right-hand side, a cochlear radio chip, which basically transmits or converts sound waves into electromagnetic signals. Submersibles, basically, that use ultrasound, similar to what sea mammals use. Dolphins, whales, and also bats, right? And my favorite of all, Chihira Aiko, which is a humanoid, android-based robot, which I had the pleasure to meet about a week before it was public in Japan. But one thing that's always been kind of a mystery, which is how come we've never tried to understand the brain better, or master it better, or even be inspired by it to create some piece of hardware or technology or software or what have you that thinks just like the brain. Obviously, it is the most complicated piece of organ, if you would, in the world. And so it's always been fascinating to me. Anything that has to do with brain, I'm always, trying to learn more about, read about, et cetera, et cetera. So until I came across deep learning, a brand new technology, not anymore, but about 3 years ago, Google, Baidu, Microsoft, and Facebook pioneered deep learning. Yann LeCun, a French American who is a professor at the University of New York, now is running Facebook's AI lab in New York, pioneered deep learning, which basically is just a bigger umbrella for machine learning. Deep learning is basically the intersection of neural networks that allow a better understanding based on massive amounts of data. So think about it just like the brain, right? A newborn baby sees the same thing over and over and over and over again, and automatically the 6th, 7th, 8th, 10th time, it understands it. That's exactly the same concept behind deep learning. So it is a machine learning technique that involves applying layers of calculations onto data, massive amounts of data, right? Deep learning today is used in 3 things: image recognition, text recognition, and lastly, sound, right, or audio recognition. So image recognition is mainly used by an architecture called convolutional neural networks, or CNN. And then you have text, and then you have audio. So Siri on your phone or Google Now on your phone does use deep learning, right? Think about I don't know if there's any ATMs here that can accept your check that's handwritten. Automatically recognizes your handwriting. If not, it's coming up. So this is an idea for some entrepreneur here in the room, hopefully. So the idea of deep learning is that it can understand better than machine learning because it can make the slight difference between multiple things. For example, for image recognition or face analytics, it can recognize the same face from different angles. For text recognition, it can recognize multiple handwritings. Same text, same content, different handwritings, it will recognize it as the same. For sound, it will recognize the same sentence said by 2 different people by 2 different accents, an American one and basically some other one, a British one. So that's basically the idea behind deep learning. I spoke about convolutional neural networks. This is the most widely used architecture for image and video recognition. This is what we're going to be talking about in a little bit regarding Iris. So CNNs are convnets or deep neural networks, DNNs. It's all the same thing. We apply that for face analytics in order to solve some really hard problems. Facial microexpression recognition, age, gender, eye tracking, head pose, gaze estimation, and so on and so forth. So Iris specializes is a deep learning-based face analytics and emotion recognition. So anything that you can extract from a face, our software basically understands it. But as in everything deep learning, the way the algorithm learns requires massive amounts of data, right? Just like a baby. Every day he learns a lot of things, and by the time he's 15 years old or 20, he knows a lot. By the time he's 60 years old, he probably knows more than he needs to. So the idea about data is very critical to the success of a deep learning-based company. or software. At the early stage of deep learning, you don't find massive amounts of data everywhere, right? You can find some unstructured data on the internet. It doesn't necessarily give you great results. Plus, you have to annotate all of that data, et cetera, et cetera. So what we did is we had to create our own database, about 1.25 million images and videos, which took us years and years, manual annotation, and it was a daunting process. It was redundant. It was really tiring and fatiguing until we started seeing some good light coming out of it. The data comprises of 5 major ethnic groups, obviously because we wanted to recognize the face of everybody in the world. Face is the same everywhere, except that it is a little bit different, or the features are the same, but it is different from one region to the other. So South Africa is different than Japan, and China is different than Southwest Asia, for example, right? So we had to collect massive amounts of data sets, which basically means we had to hire people in our labs, hundreds and hundreds of students and people that we had to pay, come to the lab, we take images and videos of them, we have them imitate certain expressions. There's 7 universal expressions: joy, surprise, anger, fear, disgust, and neutral. And sad. That's 7. Each image, we had to annotate it manually and say, okay, this is a gender, so this is a male, adult, smiling at 50%, lighting is at 60%, his head pose is at minus 30%, and that's one image. So you can imagine the variations and the matrix, right, that we created. We had to do it because we wanted to imitate the very natural environment. The data sets was also comprised of 4 different age groups. So child, young adult, adults, and senior. Our next release, which is due in a couple of months, will actually have a plus minus 5 years of age. So we're going to provide 30, and that person might be 35 or 25, but we're going to be within that range. And there is no other company or technology that can do this because people age differently. There is absolutely no standard way that says people do age the same way, therefore you cannot form a data set that you can train the algorithm on. 2 genders, and luckily there's only 2. There's always unknown, right? And I'm not referring to Botox. And there are different lighting conditions, 10 of them, 13 different head poses. So you have minus 45, minus 30, minus 15, 0, 15, 30, 45, etc. And we did this with multiple cameras. So time-of-flight cameras, IR cameras, RGB cameras, different resolutions, VGA, etc., etc. I don't want to talk too much about technical stuff, and I don't want to be super boring, but I'm going to give you like the skinny, as we say. What we came up with is the most comprehensive, most advanced piece of software that has the entire suite of face analytics. You see on top the 7 universal emotions. Then we have face detection. Everybody that has a phone here has a camera, right? That camera has a piece of software that does face tracking. Every time you want to take a picture of somebody, it does put like a little square in there. There's no reason for it, right? You don't use it. You don't know why it's there. But there is a reason why the company, Apple or Samsung, whichever company, has it in there. Because that's the very beginning of something that is useful, right? That's step 1. We're already at step 20. So it's a little bit of, a little advanced, but it's coming. So that's validation. Face detection, face tracking, 3D head pose, gaze estimation, face recognition module, right, for driver or user authentication. Multi-face detection, everybody in a room can be recognized as long as the processor can allow it. So it's not a software limitation, it's more of a hardware. That could be. Gender, age group, eye tracking, eye openness, blinking velocity, blinking frequency, et cetera, et cetera. Engagement metrics, some of the metrics we created with some of the psychology scholars in the US. So there is like an attention score, an engagement score, expressiveness score, emotion lift score, which is like how much more or less a person can be emotive from one second to the other. A mood indicator based on positive, negative, and then indifference, et cetera, et cetera. So this right here is the most comprehensive. I can't go back? Really? All right. The most comprehensive piece of piece of software that has the entire suite of face analytics. So the software is three things, three key features. Ultra lightweight, embeddable, very, very important. Embeddable means you can put that software on any device that is small, that is not necessarily, doesn't necessarily have like an operating system, et cetera, et cetera. High accuracy using deep learning. We see 96, 97% accuracy rate. And then it's race and environments customizable. Let's say the software doesn't do well in some part of Asia or Africa, then we just go ahead and collect some data set, train the algorithm the same way. Within weeks, we can have an increase in accuracy. Same thing for environment. If we're doing this for automotive, I'm going to talk about automotive in a little bit, then each car is different based on space, lighting, positioning of the camera, top down or down to bottom, down to top or bottom up approach or whatever the case it is. So the applications, we're trying to transform HMI, human-machine interface, very important, which is basically the way people interact with their phone, right? If you're using your phone. You can think about phones, tablets, wearables, TVs, computers, cameras, security cameras, automotive, gaming consoles, right? Drones, robots, any and every camera-enabled device can use our software, or our software can be embedded in the back of that camera to process information in real time without necessarily relying on cloud processing. One of the applications that we're very much focused on for various reasons, which is driver monitoring. So we work with a number of car companies today because the future car, we're going to see this starting third quarter 2017, is going to have a camera that's looking towards the driver to detect whether you're sleeping, your eyes are blinking, whether you're paying attention or not, and then the car will react accordingly, right? We have a quick video to play. I'm going to show you how this works.
The eyes may be the windows to the soul, but in the case of the Lexus LS, which eyes? Eyes that pivot with the road? That can see what light misses? Eyes designed to warn when yours wander?
Right here. This is the applicability of our technology in a car. This is a commercial running today in the US. It's a very high-end Lexus, but it's a good start. They don't sell too much of it, but it's a very good start, right? The second application is, I mentioned earlier, robotics. There is a very popular social robot now in the US and everywhere else in Asia, about at least 5 companies that I know of that are working on this, something that will replace the phone at home. Basically, when you go home, you're not going to use your phone, you're just going to use a social robot. It's a tabletop robot the size of this little bottle. That basically can do everything for you. It can listen to you, can respond to commands, it can take pictures, that is connected to the home, that does a lot of things. We have another video to play. Go ahead, Nofal, please.
Jibo is the world's first consumer social robot for the home. And right now we're in phases of development production.
He can take photos, he can take videos, and he can track your face and recognize you.
The core feature of Jibo is individual identification. So Jibo starts to begin building a user model for each family member. Facial recognition is absolutely key to our relationship with NVIDIA and our reliance on the TK1.
Jibo has the ability to learn with its AI programming. It relates to you by communicating and expressing itself using natural, social, and emotive cues so you understand each other that much better.
Oh, your house in!
Hey, where'd you go? There you are.
Good night, Jibo.
Very cool. But a $750 product. It's already in pre-orders. They will be delivering the first batch, which basically was ordered about 8-9 months ago or even more, sometime in 2016. So This gives you an idea about where the technology can be used at what scale. Okay? The third applications, and this is the last one I'm going to talk about as far as applications, is video analytics, video viewer analytics. So think about Procter & Gamble, advertisers that spend millions of dollars on advertisements that really either go into TV or don't make it on to TV, that sometimes end up just online, right? There is only one way, and one way since back in the 19 whatever, to measure how people react and respond to a certain video before it airs. How do you test a commercial to know it will work or it will not work, right? Typically, it's called surveys or focus groups, right? On a smaller scale. It's very biased, prone to error, and obviously difficult to scale, right? What we created is a platform where it's a web platform where advertisers or movie production companies or networks, TV networks, any video production company basically can go in and upload a video, share that video with thousands of people, panelists, Anwar knows best about this, from Veilings. And basically these people will just click play as if they click play on a YouTube video, right? But then they're going to be prompted to allow their camera to look at their face, the camera that's on their laptop typically, and then watch the video naturally, right? What generally happens is the second they turn that camera on, the software in the background starts analyzing their facial micro-expressions, their gender, their age group. There's also other variables and things that we collect, such as geolocation and things like that, so we can provide great analytics. So the idea here is to tell the content creator that second 15 of the 30-second TV commercial provoked a smile among the male audience, provoked nothing among the female audience that's in New York. However, the female audience that's in Texas did find it to be interesting, and it provoked also a smile or a surprise or a disgust or whatever the emotion is. Things and insights that they have never seen before, right? And all of this on a dime. And, we can put together a campaign in less than 24 hours, and it would cost them about a tenth of what a focus group basically would cost them, right? Same thing goes for studios, movie production companies, trailers. There's tons and tons and tons of videos that are being uploaded to YouTube every single day. And so either they are not tested or they are tested poorly. If you go on, I can't go back, right? Okay, so this is basically kind of a dashboard. It's a mini dashboard that you can go ahead and try on iris.com. This is a TV commercial that did really well. It's a potpourri, if anybody knows about this, but it's pretty hilarious. 3 integration solutions: mobile SDK, desktop SDK, and then cloud API for any developer or anybody that's interested in working on or building something with this platform. And that lets me segue into ambient intelligence, right? Ambient intelligence is keyword for the next decade, which basically refers to electronic environments that are sensitive and responsive to users or to the user's behavior, right? Or to the presence of people. That is based on what we call sensor fusion. So you have cameras, that's one sensor. You can have, for example, heart rate monitoring. You can have motion. You can have all kinds of sensors, and these things can passively, in the background, without you knowing or seeing them, can respond accordingly and make your life a lot easier. Imagine you go home, before you walk home, your car knows your body temperature, therefore it sends a signal to your home knows exactly whether you're cold or not, and it adjusts the temperature 15 minutes before you get home so you can find the comfort that you're looking for. That's the kind of ambient intelligence that I'm talking about. This is exactly what we're going to see within the next 10 years. Okay? That's just one example. Obviously, ambient intelligence will lead into something big, the fourth industrial revolution or era. Some people call it the AI era, the artificial intelligence era, right? We hear a lot about artificial intelligence, and the reality is it's only artificial at the beginning, because after that it becomes the norm. It becomes, it fades into the fabric of life. Today there are three types of AIs. The AI that you guys know or knew for the last probably 10 years, which is artificial narrow intelligence. Single-threaded tasks where a computer can perfect something and one thing only. Take, for example, a computer that beats a chess player every single time, but that's about the only single thing that computer can do. Single-threaded, artificial, narrow intelligence. Second thing is artificial general intelligence, which is the artificial intelligence that we know. Basically, it is kind of at the same level of the human intelligence today. It's what operates your phones and your laptops and your devices and some of the cars and some of the smart homes, et cetera, et cetera. But then we're moving more towards artificial super intelligence. And 2016 looks like it's moving more and more towards this. This is based on Frost and Sullivan, kind of a report that they just came out with last December, which they sent me like the executive summary of after participating at some panel with them. But this is exactly what we're going towards. This is exactly what we're going to see in the next decade or so, right? So artificial super intelligence, which basically beats the human's understanding, beats the human intelligence. And that's what you hear sometimes. People say, robots will overtake the world and the machine will basically start killing people and all kinds of crazy stuff. Some people call it Life 2.0. Obviously, because of a number of things. We're going to talk about the picture on the top left corner, which is the mobility revolution. It's going to cover everything here. So the mobility revolution is based on a good friend of mine called Lucas Neckerman wrote a book called The 000. He's out of London, and the 000 basically stands for zero. Anybody has a hint or a guess or can guess or I can give a hint? No? So, zero gas, zero accidents, and zero ownership. Right? What happened here? Is that it? Okay. Thought I had another slide somewhere. Okay. So the mobility revolution is basically where we're heading, at least for some countries that have great infrastructure, that have the ecosystem that can allow it to happen. And earlier I talked about driver monitoring. One of the reasons why we do target driver monitoring is because it's a market that comes to us. Everybody's super excited about autonomous vehicles, and then there are two applications. When you have a car that can drive on its own, sometimes, meaning it's quasi or semi-autonomous. When the car is driven manually, you have the driver who's tired or can close their eyes. The car can respond accordingly. The steering wheel can vibrate if you're falling asleep. The car can also transition into autonomous mode, right? But then before it does, it needs to make sure that the person is, number one, present at the seat. paying attention, their eyes are open, they're looking at the windshield, they're not texting or talking to their passenger, et cetera, et cetera. Similarly, when the car is in autonomous mode, but it hits an obstacle, there's a tree on the street, there is bad weather conditions that will prevent it from driving autonomously all the time, it generally takes about 10 seconds to hand over the driving operation to the driver, and that within that 10 seconds, that's when our software kicks in to look at the driver and to make sure that they are present, their eyes are open, et cetera, right? If they are driving manually, the car can also transition back into autonomous. Very important. So when this happens, we're going to achieve the 000 or the zero ownership, zero accidents, and zero consumption or zero gas, right? One of the slides that I don't find here for some reason is just about the state of the Moroccan startup. Like I said earlier, I had the absolute pleasure of working with some of the startups and mentoring them, and I've seen probably a couple of dozens at least, great ideas, et cetera, but a lot of them have very similar challenges. Some of them do have financial challenges, but some other ones have red tape is what we call it, government challenges. They cannot bypass certain things. They will have to lobby. They need you, the ministry, to help them with some programs and things like that, right? So I did a little bit of homework just over the last couple of days, and I came up with about 4 industries, 4 sectors that can benefit greatly today from the disruption that the startups and the entrepreneurs can create. Number 1 is I was stuck yesterday and I couldn't catch a cab, and it took me 30 minutes before I can take a cab. Transportation tech, right? Why are we waiting for Uber, which actually just got here for like 3 months ago, to become popular in both, here and Rabat and all of the other cities? Why not some entrepreneurs just go ahead and start that piece of software, right? Just copy it, right? And beat Uber to it. You know the idea, it's validated, it's a $50 billion company, right? Why not, right? There is also some problems and challenges, rather, with ag tech or agriculture tech, right? Morocco is mainly based on agriculture. It's an agriculture country. So there's a number of sensors, technologies that are being developed elsewhere that can be either cloned or utilized or innovated, or can be innovated and created here from scratch, right? There is, for example, seeding processes in order to eliminate waste, and there is all kinds of things. Another problem that I realized is also logistics for shipping, right? You ship something from overseas and you kind of have 50-50 chance that it may make it. Probably more than 50, but a lot of things get lost or do not get delivered for some reason. There's a company out of the US called Ship, SHYP, that just competes with the post office and FedEx and UPS. Just 3 young guys. They do the same exact thing. They make sure that package gets delivered, right? It's not an address problem. It's probably a logistics problem. There's also fintech, right? Fintech. Some of the greatest startups in the US that have made it big, from PayPal to Coin to some other great companies, create new novel technologies in fintech, right? I understand the red tape, I understand the governments, I understand all of that, but there is opportunity, and when there is opportunity, you should go for it. Nothing is easy. Entrepreneurship is easy. Waking up this morning and coming here at 9 or 10 in the morning is not easy either, right? So just keep trying. Just do it. Got it. So that's pretty much it. I wanna open it up for questions. We have about 7 minutes for Q&A. Okay. Please make it brief, quick, ask your question briefly, compose it in your head before you say it so that we can answer as many questions as possible. You can go ahead. Thank you. Don't be shy, go ahead. Go ahead. Just present yourself and go ahead and ask. My pleasure, thank you.
Thank you. I was expecting to see three informations, which I think are very important for people here in startups. So the first thing is, how did you come up with the iris idea? How did you go from having the idea only to starting a company, going through the early stages, and then becoming such a successful company? And the third thing, what were the major challenges you had, and how did you overcome them?
Yeah.
Thank you very much.
So, yeah, thank you. Great question. Number one, I got pulled into it, right? So remember I mentioned I have a background, consumer behavioral measurement. 2008, we started a company. It's an advertising company. It was the first FTC-compliant facial recognition measured in-store TV network. Just like a fancy name for a bunch of TVs in airports and shopping malls that have a little camera connected to a computer. And that camera does, in real time, face and Asian gender analytics, and it broadcasts advertisements according to your gender. If you're within 10 feet or 15 feet or 5 meters, 3 meters, right? From a display, you're walking towards it. It has a camera. It recognizes you as a male, and it broadcasts a Gillette commercial for you because it knows you're a male, right? This is 2008. It was a bad time for advertising, but this is basically what led me to, that was Iris TV. This is what led me to Iris, right? So 2011, we started a small R&D project. My co-founder, Steven David, has a PhD at University of Miami, is basically obsessed with facial microexpressions, and hired him as a consultant, lived almost in Miami for 1 year, just commuting between Orlando and Miami, and we put it together. The guy is brilliant, and he knows exactly what we wanted, and he just built on top of what we had, right? We grew into a certain stage where we couldn't grow anymore. That was in Florida. Florida is not really techie and all of that. A lot of rednecks, sorry to say that. And then I had to move to Silicon Valley, right? So there's an ecosystem. Yesterday, somebody asked me at the radio, what works in Silicon Valley doesn't work elsewhere. It's an entire ecosystem. Your clients are all within 5 miles radius. You have a banker that helps you raise money. You have banks like Silicon Valley banks that open a free bank account for you for 2 years. They work for you, literally. They can connect you with anybody you want. You have lawyers that give you, for example, a $10,000 to $15,000 of advance. You don't have to pay anything, really. Just go to the best law firm in Silicon Valley and tell them, I have a startup. Do you like my idea? Great. I don't have money. I'm going to owe you 15 grand, and I'm going to pay you in 2 years. So these are the things that really help you. Obviously, it's not easy. I'm not trying to make it easy. It's not easy, right? Rent is expensive, for example. You can't afford a 2-bedroom house. It's 3 grand, right? Or apartment. So it's not easy, but there is a price to pay for such a place, and there's a reason why there's only one Silicon Valley in the world. So that model doesn't even work within the U.S., right? So this is a long answer to your question. It's a great question. Actually, 3 questions. But yeah, thank you. Next question, please. Do we have any time? 2 minutes. You can answer 2 questions. Go ahead.
My name is Amin. I have only one question. It's about, do you think if you start this project from Morocco, would you have the same result?
No, not really. Good question. Not really. So you do have to create products that solve local problems, right? It's not a local problem. It's a futurist product anyways, even for the US, even for Asia, right? I would have probably created another product that would work for Morocco if I wanted to stay in Morocco and only sell in Morocco. But a great question. We can answer one more question, please. Go ahead. Let's have a female. Go ahead. Your name, please? Okay. Very good question. Who do you work for? Okay, so we don't store data. Everything is processed in real time and shredded in real time. We cannot process data. It's a non-privacy invasive product. Otherwise, we're going to have a lot of things. We can store data, of course, when people consent and say, yes, I'd like to turn my camera on, and it's okay if you want to keep my video. But we don't want to keep those videos anyways. Otherwise, we're going to end up with like a city-wide of like servers that are like bigger than YouTube, and it's really pointless, right? So we need the data, not the video, not the mass storage, et cetera, et cetera. Are we good? Thank you guys very, very much. You have a great program ahead of you. Thank you so much. The plan.